I think that there are a few different directions in which we could go at this point, and maybe I'll try enumerating them, and you can see what makes sense. They all have to do with a guess at the riddle, but one way is to stick with some high level issues because you describe two ways of using quantum mechanics to get a better understanding of the metaphysics of our world, two approaches, top down and bottom up, that might be interesting to get into. Another one is you in the course of this story, Maxwell brought fields into the ontology of the world with his equations. And this, of course, has a parallel with the introduction of the wave function to the ontology of the world. And we might talk about wave function realism and its gnomic alternatives propounded by the primitive ontologists. And then the third possibility is ways of dealing with locality, non-locality, perhaps by rethinking or talking about our notion of space. But whatever you want to do.
So those three questions are in fact intimately related to one another. So yeah, so maybe I'll. So it's nice of you to ask me to be a guest on your show in conjunction with the very recent publication of this book of mine called "A Guess at the Riddle," and so I can say a bit. So I can touch on all three of the questions you raised by talking a little bit about what's going on there. So look, as I said, what happened, I would say about 20 years ago or 25 years ago, is that people like Tim Maudlin and Shelley Goldstein and Barry Lower and Nino Zanghi and a bunch of other people and me thought we were done making the case that Bohr and his circle were wrong, okay? That the measurement problem was a scientific problem, that we already had several proposals for solving it on the table. We don't know yet which of those proposals is going to turn out to be the right one. The different proposals, in many cases, differ in empirically discoverable ways, although the experiments we would need to do in order to distinguish them from one another are beyond our current technological capabilities. But we thought we had finished making the case that this was a scientific problem, not the occasion of the scientific confrontation with the eternal, ineffable mystery of being or something like that. Okay. We thought we had finished making that case. We thought we had, as it were, cleared, established a clearing in which the project of learning about our metaphysics from our physics could get up and running again. And questions about what the basic ontology of the world is, and so on, questions about what the basic structure of space and time are, which were the traditional concerns of metaphysics, but as very much informed by physics. That conversation between physics and metaphysics could get up and running again. And as I mentioned an hour and a half or so ago, something interesting that happened is that this collection of people like me, Barry Lower, Tim Maudlin, Shelley Goldstein, Nino Zanghi, lots of other people, found that although we were finishing each other's sentences in insisting that the measurement problem was a scientific problem, in resisting the view of Bohr and his circle, the minute we felt like that job was done, not that everybody was convinced, but that anybody who was willing to read the stuff and think about it would be convinced that we had said all we could say. The minute we figured that job was done and we moved on to the obvious next job, okay, what is the ontology that this theory is depicting for us? How do we read the metaphysics of the world off of this theory? The minute we turned to this other problem, we found that we weren't in lockstep at all anymore, that that we all had very different intuitions about what looked like the obvious ontology to read off of these theories. And I think there was a bunch of looking around at each other and saying, "My God, I thought I knew you. How could your I thought we were all thinking about the same thing. How could your intuitions about this have turned out to be so different from mine?" But we did find that we were left with very different intuitions about what the obvious way to read off ontology and metaphysical structure from these solutions to the measurement problem that we had, what the right way to do that would be. It always seemed just very natural without even thinking about it much, that the question you wanted to ask yourself in order to read off ontology from these new versions of quantum mechanics we had is to ask yourself a question like, what is to this quantum mechanical theory as particles are to Newtonian mechanics? Okay? Particles, everybody agrees, are the fundamental ontology of the world that Newtonian mechanics is telling us about. Okay? So the question you want to ask yourself is, you look at the logical structure of the theory, you look at the mathematical structure of the theory, and you ask yourself, what stands to this theory as particles stand to Newtonian mechanics? Or equivalently, what is it that the equations of motion in this theory are the equations of the motion of, okay? Just as the equations of motion in Newtonian mechanics, like F equals ma, are the equations of the motion of material particles. If you ask yourself the question that way, the answer is perfectly straightforward and trivial. The equations of motion of quantum mechanics, the equations of motion associated with quantum mechanics, are the equations of the motion of the quantum mechanical wave function. Okay, on Bohrian anti-realist pictures of the world, the wave function, like everything else in the theory, was not to be interpreted as a physical object. Okay, it was some kind of mathematical device which helped you make predictions about the probabilities of the outcomes of experiments. But the minute you've solved the measurement problem, you've eliminated the obstacles to taking this theory realistically, and you try to take it realistically, and you approach the question of what the theory is about, okay, in the way that I just described, the answer is just immediate. The theory is about the wave function in exactly the sense that Newtonian mechanics is about the motions of material particles, and in exactly the same sense, and this is a closer analogy, as Maxwell's equations are about the evolutions of electric and magnetic fields. Okay? Good. This is what I'm referring to as the top-down approach. You start with the mathematical formulation of the theory, and you ask yourself, what is to this theory as particles are to Newtonian mechanics? Good. You're immediately, trivially led to the answer, oh, it's about the wave function. It seems like, if I follow this analogy with Newtonian mechanics and with Maxwellian electrodynamics, the concrete physical object here, whose evolution is being described by this theory, is the wave function, okay? Now, the minute you say that, you have questions to answer that you don't have in the Newtonian case, and you don't have in the Maxwellian case. And that's because, unlike Newtonian particles, and unlike Maxwellian electromagnetic fields, these wave functions, which you're now declaring are the fundamental concrete objects of your ontology, are things that undulate around, not in the familiar three-dimensional space of our everyday experience of the world, but in this very, very high-dimensional space. And And so the minute you say, gee, I guess what I'm getting from this theory is that the concrete fundamental physical objects are these wave functions themselves, then it seems like what you're committing yourself to is a claim of the form that the stage on which the real, precise, microscopic history of the world plays itself out is this very high dimensional space, not the three-dimensional space we're used to. And the first question that you're going to want to answer, or one of the first questions you're going to want to answer is, okay, then you're going to need to tell me a story about why it is that that our everyday macroscopic empirical experience of the world is as of a three-dimensional world. Okay. Our experience of the world as three-dimensional must, if this is true, be in some way misleading, or not the whole story or something like that. And you're going to want a story about how these three-dimensional appearances get produced, okay, by these undulations of this concrete wave function object in this very high dimension space. And one of the first stories that you want to tell, if you're reading the theory this way, is how the mechanics of the production of these three-dimensional appearances works. And, you know, one of the burdens on anyone who's trying to defend this kind of wave function realist view is going to be to tell a story like that. And a lot of papers I wrote since, you know, the first time I know of that this wave function realist view was put in print anywhere was in a paper that I wrote, I think sometime in the late 1990s. And obviously the questions that arise the most immediately are these questions about, well, where do these three-dimensional appearances come from? Tell me the story of those. And I've spent a good deal of time in the years since then trying to make it clear how that story goes. I think the story is, in fact, surprisingly simple and straightforward and has to do with the structure of the dynamical laws and the way the structure of the dynamical laws it has to do with taking seriously on board the notion that the way things appear to us is more a matter of dynamics than basic ontological structure. That's a bit of a long story. But anyway, I've spent some time trying to tell that story. There are other people like Shelley, people like Tim, people like Nino, who had a very different reaction from the word go. Okay. They said, look, the minute you realize that just doing this little game that I just described, okay, you ask, what is to quantum mechanics as particles are to Newtonian mechanics, whether the quantum mechanical equations of motion, the equations of motion of, the minute you notice that this way of trying to answer the ontological question is going to commit you to this very high dimensional fundamental space, you ought to come to your senses very quickly and see that this shows that this approach you were taking is just a non-starter. Okay. The approach is very intuitive. I see the appeal of it, but for God's sake, grow up. Okay. 2 or 3 steps into it, you're supposed to see that this commits you to preposterous claims about what the fundamental space of the world is. Indeed, lots of these people seem to be convinced. I don't want to misrepresent them. Seem to be convinced that any claim to the effect that the sort of three-dimensional objects of our everyday experience of the world, tables and chairs and haircuts and universities and stuff like that, are really the undulations of something in a very high dimensional space. It feels to them just like a complete non sequitur, like apples and oranges. That is, you say, how would things have to be undulating around in this high dimensional space in order for there to be tables and chairs here? It seems to them like asking, how would oranges need to be moving around in order for there to be an apple? Okay. And you say, look, there's no way for oranges to move around such that there would be an apple. Okay. They just have nothing to do with one another. Okay. And this is a complete non-starter. And it stands for them as a very fundamental feature of our empirical experience of the world, that there must be in the fundamental metaphysical structure of the world a fundamental three-dimensional space. Otherwise, the business of making connections with our empirical experience of the world just never gets off the ground. Okay? So this was a very basic difference in our intuitions. Okay? And this led them to develop these primitive ontology views, these gnomic attitudes toward the wave function. You say to them, wow, taking the wave function to be a law, it's so awkward. It feels so goofy. So the wave function is a gnomic entity, but then there are laws of the evolution of the wave function. So there are various levels of laws, stuff like that. They perfectly well understand all this, okay? They just think that the other approach, the minute you start identifying the fundamental structure of the world with this higher dimensional space, it's just a non-starter. It's just a non sequitur. There's going to be no way to make a sort of, intuitive, explanatorily useful connection with our everyday three-dimensional experience of the world. I don't think that's true. Indeed, I think there's a nice way to make this connection. And one of the things that's happening in this book is that I thought recently that I found a much more compelling way to sort of lead a reader or a listener to this high-dimensional wave function, realistic picture, what I call a bottom-up approach rather than a top-down approach, where, as I was just describing, in the top-down approach, which is what we've just been talking about, you start with the finished mathematical formalism of some physical theory, Bohm's theory, or some other way of solving the measurement problem, some other version of quantum mechanics that incorporates a solution to the measurement problem so that you can begin to talk realistically about it at all. You start with this finished mathematical architecture, and you begin to ask what kinds of metaphysical pictures of the world could be sort of draped around this architecture of a mathematical theory in such a way as to fit with it well. Okay, so you ask yourselves these questions that I just described asking. What is to the quantum mechanical mathematical structure as particles are to the Newtonian mathematical structure, or something like that? That's what I'm calling a top-down approach. The reason I was inspired to write this book is that it occurred to me that there was a very different approach that's supposed to lead to the same place, which is the reasonableness of this high-dimensional wave function realist picture, but leads to it by quite a different route. You ask yourself the kinds of questions that people should have been asking themselves in the very beginnings of quantum mechanics 100 years ago. Wow, these subatomic particles are behaving really strangely, okay? These experiments are coming out in ways that are really weird. What kind of a thing would a particle have to be in order to behave this way, Okay. So you ask yourself the sort of nuts and bolts in the weeds, scientific kinds of questions, which if Bohr and his circle had been honest, reasonable, scientific workers, they would have been asking themselves in the first place. Instead of, creating this whole mishigas with Hegelianism and I don't know what. Good. And I found that if you allow yourself to play very, very simple games, cooking up toy theories, very simple versions of theories, incorporating a higher dimensional space, but just slightly higher, not much higher, like in quantum mechanics, but you go from a one-dimensional space to a two-dimensional space or something like that, and imagining things knocking around in this higher dimensional space and asking yourself how those things would look if you look at them from the perspective of a lower dimensional space of our experience. And the striking thing was, the minute you start to play very simple games like this, behaviors that are sort of distinctively quantum mechanical, behaviors that are sort of the signature behaviors of quantum mechanics, just fall right out, okay, the minute you start playing these kinds of games. So that was very striking to me. It was very encouraging. It looked like a much better and more compelling explanation of the quantum mechanical behaviors than the top-down kind of explanation. So that's what suggested to me to write a short book, even though I had been, talking people's ears off about this wave function realism for 20 years. This seemed to me a completely different and much more compelling way to approach it. Mind you, a big part of the reason I stole this title from Pierce, okay, a big part of the reason the title appealed to me is that the title, and I hope you'll agree if you've seen the book, I hope has a kind of modesty about it at the end of the day, okay? I don't think I wrote, the first book I ever wrote, which was like 40 years ago, a book called Quantum Mechanics and Experience, okay, was a book that was very much involved with this first project of resisting and refuting the anti-realism of Bohr and his circle. And that book was very much the book of a angry, very confident young man, okay? And, it was what Sidney Morgenbesser used to call the Edward G. Robinson approach to philosophy, which is that you just suddenly bust through the door with guns blazing in both hands. You kill everybody in sight, okay? And you tell people what the truth is, okay? Here I take myself to be in a different position, okay? Here, I'm not sure I see a knockdown argument that the primitive ontologists are wrong. I'm not sure I can see, because we're getting into metaphysics after all, how there are ever going to be fully decisive arguments about this. I think that to the extent that I can get somebody to see how this new version of a wave function realist picture works, you have this feeling that if you can just yell at them for long enough about it, they're going to see how much more explanatory it is. It's this feeling of like you're looking at one of these optical illusions of a vase and two faces looking at each other, and you show it to your friend, and your friend says, "I can't see the faces." And you say, "Come on, don't you see? Here's the nose, here's the mouth, so on and so forth." And you say that to them for a little while, and they say, "Yes, of course. Now I see the faces." I'm hoping it's like that. But when I wrote my first book, I was in a way in a much more fortunate position. I was in the happy position of just pitting myself against people whose views were riddled with trivial, outright, stupid logical contradictions. Okay. So it was just easy to come in and shoot the room up and kill everybody in sight. Okay. And say, we got a bunch of new rules here. This is a different exercise. This is an exercise in arguing that if you really think about it, I can't imagine that you're not going to find this the most compelling explanation of these phenomena. And as I say, what suggested that after all this time of bending people's ears with this wave function realist view since the 1990s, what suggested I write a new book about it is I found a completely different and what seems to me a much more compelling way to claw your way towards it. From the bottom, starting with the weirdness of the behavior of these subatomic particles and asking yourself, what the hell kinds of things could behave that way? Okay, rather than starting with the full mathematical formalism of a theory of their behaviors and asking yourself what kind of metaphysical picture of the world went along with it.